Hello, everybody. So I'm gonna take just a second here. I'm running a little bit late, as you may be able to tell. So, let's see here. What are we doing today? Today, we are taking a look at pdfcrack again. Hello? Hello? Nope, that sounds better. Yeah, that seems fine. Okay. So, where was I? A second here. I am still logging into things. That's not what I wanted to log into. Oh, close enough, I think. Right. So we are taking a look at the pdfcrack again. Hopefully, we are completely finishing up with pdfcrack because we've been looking at pdfcrack now for 2 weeks, and hopefully, we're just done with that. While it wasn't awful, it was definitely taking longer than I would ideally like it to. So we're going to take a look at that real quick. Hopefully that'll be pretty quick, fairly straightforward, be done with it pretty quickly. And then what I'm hoping to do is actually go through with Manticore and see if we can generate some of the inputs. So I spent some time this afternoon playing around with Manticore, talking with the guys in the Empire Hacking Slack, which is the one they do their I don't want to call it support, but feedback, help, whatever you want to call it, is in there. And if it'll load, I will be logged into it in just a second. Come on. There we go. Okay, so that's up. I have this up. And I have that up. So, where were we? So I should have here the PDF stuff, which has our crashes and our outputs. And do I have a copy of... No, I do not. So, where am I going? I want the... So, the VMs that we were using in EC2 to do a lot of this fuzzing on, I shut those down and pulled them down. Didn't make much sense to keep fuzzing. We've had plenty of time already just pulling up the outputs, checking them out, and doing all that. Doesn't make sense to keep fuzzing it. That's... it seems like it's a little bit... wasteful to just keep fuzzing, especially since, taking a look at it manually and didn't really find anything. Oh, this is not going to work, is it? Is it? Is it? Yeah, that did actually work. Okay. So what are we doing here? I want to do GCC make. Just make. Fortunately, that means I need to get set back up again. So we now have our pdfcrack. That looks like what I want. So we shall, let's go a level down here. Oh, screen. pdfcrack. Where are we in here? So if we go in here, 04 crashes. I believe this is where we were working. We should be able to do find /04/crashes -exec -pdfcrack-l the file, run it. What? Oh, crashes. Fortunately, this is not giving me what I was hoping it would give me. For crashes ID 20. We don't have a core. Okay. Dash dash args, bang bang. Not what I wanted either. Okay. This should be what I wanted. Oh no, that's our other one. Okay. Sorry everybody, this is taking a little while. Looks like there's a couple people watching. I'm not sure who all saw the one yesterday, so or Monday. So on Monday we took a look at the CTF binary, went through it real quick, played with it a little bit, and then we took a look at Manticore. So Manticore is from Trail of Bits. It's I don't want to say it's the only thing they're doing with symbolic execution, but it's at least something they're doing with symbolic execution. The short version of it, are we just doing the same file over and over again? Seems weird. But so it's the short explanation is that it will take a binary, you run it through. Yeah, a lot of these seem the same, don't they? So that had the same. Oh, no. Wait, I know how to do this. Duh. Well, now that I think about it, let's do this the easy way. 04 crashes ID 20. And we can call this input.save. So if we look at this. Anyway, what I was saying was that, so Manticore is a symbolic executions tool by Trail of Bits. There's a couple of guys there. I think it's mostly Mark and Yan, but I might be completely wrong about that. At least they're the ones that I've been talking to in their Slack about it the most. And hopefully we'll be able to do some cool things with it. I played with it a little bit this afternoon for solving for some inputs to a function. Hopefully it'll be something good to play with, though. So, where were we? PM was 1, I think? This is not a good input. 04 crashes. What's a good? Let's try 18. No. 19. No. Oh, 1. So let's see if we can remember here. Word list was not the one we wanted. Is that correct? Dash L dot dot 04 crashes ID 001. What if we go into the queue? So I think if we take that first one, 04 slash q ID 0000, let's call this input.sav, pdfcrack dash L input.sav. Yeah. Can everybody hear me okay? It sounds a little bit different to me on the headphones, and I don't know if that is just me or if there's some sound problems. If you can hear me fine, can you say something in the chat so I can hear it? Oh, I wouldn't hear you, I would see it. Yeah, look at that. That totally does what I was hoping to see. So if we then take a look at this, I would expect that if we go many characters like this, we should see. Yeah, that's what I was looking for. Okay, so let's take a look at this real quick. So where were we? So the input was, if we come in here, we take a look at this. We were in, do I have tags here? No. I want to go into main.c. We start this thing up, and we will do in, where is it? Not a valid PDF, cannot. Here we go. If recovery, we want to load state. In load state, we will eventually do PW load state. And in PW load state, if we are a word list, we will eventually do a fscanf into string, which is malloc of a size that we control. So basically what we're doing here is we control the size of the allocation, and then they're going to essentially stir copy into that as many bytes as we want up until that new line. So with that, we basically get to write into the heap data we want. The trick here is that there's nothing after this on the heap. So we need to get an allocation before it that we can take advantage of. So let us do exactly that. Dash dash args, bang bang. So we will break on malloc, and let's just run it. So I think, yeah, we're currently running on a, let's get rid of one, break on main. So unlike the ones we were doing last week, this time we're on a 64-bit process. Not sure how much that matters. If we do decide at some point that it matters, we'll switch back, but at least right now, I don't really care. Crap, what's the syntax for this? I want the GDB command, GDB, look, we Googled that last time, didn't we? Oh, it's just commands, okay. So I want to print /x $RDI, because that's going to be the register they're passing in the size. I just want to continue. So if we continue now, I should see that we, oh, right, I wanted silent in there. Let's wait and do this again. So I want to break on main, run, we get to main. I want to break on mallocs now. Commands, silent, print /x, RDI, continue, end. What we're doing here is we're saying don't print out all that junk that we had there, but every time we make malloc, tell us how much we're mallocing. So we come in here. Here are the mallocs that we made. So before we did anything, we made some mallocs up here. And then we also made some mallocs down here. And eventually we crash. And I believe the one that we care about, the one that's going to that causes us to actually overflow, is this one right here, the 2, because it's going to take the length we gave it, which was 1, and it will, I'm sorry, I'm kind of blanking here for a second. It will malloc that plus 1 byte to null terminate it. So what we would like to do is we'd like to get this 2 to line up such that we can get into another spot. Because right now, where? Hello? Hello? I appear to have lost input altogether. I don't know what is happening. Oh, there's my mouse. Gotta briefly. Oh, there we go. Okay, let me see here. Give me just a second, I'll be right back. I'm gonna fix that real quick, and it should take just a minute. In the meantime, you can continue to hear me, but there's a few things I need to turn off because I forgot to earlier. basically, the problem that we've been running into here on the previous streams, there's two pieces of it. One is my computer is deciding that it would be better to underclock my processor on me, because for some reason that makes sense. And then in addition to that, I may or may not have backups running while we were trying to do the stream, and both of those cause problems. So there we go, and we're back. So where were we? We were taking a look at this. We were saying that the 2 right here is the allocation that we can overflow. And unfortunately, that doesn't do much for us. However, if you remember from last week, we said that, where were we? Up here, when it parses the arguments to this, it will take, if we give it this -L input twice, it will free the first one. And that's what we want to trigger. If we can make it free that first one, then we're set up pretty well. Alternatively, we could do something like we could supply a wordless file here. It'll free that. I believe in load state, it might free some stuff too, right? Looks like it does not. But there was another condition in here that it would potentially free stuff. But the important thing here is that if we do it up here, so if we supply 2 -L arguments, it will malloc for the first one. It will then free the first one, malloc a second one, and then after it does that, it will conveniently malloc stuff for E. Where is E? Yeah, E is malloced, and that is very nice. You know what? Let's just do this real quick. Printf %x size of ink data. I would like to know how big this is, because ideally what we're going to do, actually, we don't care. I was thinking if we knew what size it was, that would help us, but I don't think it actually matters that much. Where were we? Because what we're going to do here, we look at the sizes. So we have one allocation of 10 bytes, one of 228 hex, one of 1,000 hex, 10, a 9, 2 20 hexes, a 2, and that's the one that we're going to be able to overflow. So if we supply a -L argument, which is at least 33 bytes in size, then it will have to make an allocation and then free it that will be filled with our hole later on when we try and fill it. So let's do that real quick. So the first thing we're going to do is we're going to make this 33 bytes in length. And let's kill that for now. There. Wait, just a second here. I'm going to respond to that real quick too. Anyway, sorry. Where were we? So we do this, and then the other thing I want to do real quick is I want to say, what do I want to call this one? Args? Args sounds good. So I'm going to write a file here to do this, just because I think it's going to be easier, right? 1, 2, 3, 4, 5. So that is 10, 15, 20, 30. I have no idea how I just counted that high. That is 28 minus 4 is 14. Okay, I cannot do math right now, apparently. I want to open args. We want to write to it. f.write a times 33. That I know works. -L that -L single A. So now, show. So if we do, oh, -L is going to be the file we give it. Okay, we can do that. Input.sav. Okay. Args set args cat args. There we go. Yes. Okay. So, I believe that if all of this works the way that I expect it to, yeah. Oh, no, the file doesn't exist. Okay, so we need to do that too. Why did it keep that input? That's interesting. Right? So for some reason, it took the second, the ordering is reversed. I messed that up. Continue. Why is it still trying to do that? So error file not found with A's in it. Am I just being dumb about this? Yeah, I'm being dumb about this. It's because it's taking the 33 bytes out of this and trying to get it there. That makes sense. Where were we? Word. Place this with, I believe, a D is the one that we had. Actually, let's do this the easy way. Control A2, echo an A into this right here. We run it again. Continue. What? Oh. It helps if you're in the right directory, doesn't it? Okay. That looks better. But it still didn't give us what I expected, right? What I expected to see here is I expected to see a segfault for other reasons. Well, let's just check and make sure, right? Before we go crazy about it. So what I'm expecting to see here, and that I'm not seeing here, is the allocations lining up the way that I want them to. That's unfortunate. So the alternative we can do here, what do we want? How do we want to do this? So, trying to think of what the best way to handle this right now is. What I'd like to do is I'd like to get the returns from all of our mallocs too. And at least the way that I set this up, that's a little bit difficult to do. Because the way that I set it up to print all this stuff out, it's a little bit clunky to do that. What's the easiest way to do this? So if it's going to be difficult, I don't want to do it. So one of our options here is we can go and write our own wrapper for malloc and use that. That would tell us a little bit about why it's failing. Although I'm not sure that's exactly what we want to do. Oh, sorry. Excuse me. Hoping I'm not catching the cold that one of the guys in the office has. That would be unfortunate. He's just getting over his, so hopefully I'm not getting it. Unity has nothing to do with this. Like, yes, there are problems with Unity, but You have heard that the next version of Ubuntu is moving away from Unity. They're apparently going back to GNOME as their default window manager. But what was I saying? We want to track our heap allocations. And so one of the ways we can do this is we can go and get just one of the heap tracking things and do that for us. Or, this might be a little bit more interesting even, we can do the GDB Python stuff. Because this is something that I always have to look up. This is not what I want. I think this is the one that I want. So you can use Python inside of GDB. You can do a lot of things with it that do a lot of stuff. But we can do this. This is one way that we can handle things. What's another way that we can handle this? Let's run again. Yes. What exactly is malloc doing here? So we will call... Let's fix this. So we have this. We call memoline. We're going to move... So I believe, right? No. What is going on? Okay, so what are we actually doing here? So whatever this malloc is, whatever the symbol for malloc, its plan libc actually is. We take this, we juggle some arguments a little bit, we memoline first. We call the memoline to actually align what we're asking for. What? We jump into the... I don't trust what I'm reading at all. So, like, I will perfectly buy that the first thing we do here is we memoline and make sure we're giving it a round argument. However, I don't see us returning from this, which is a little bit concerning. But memoline not do what I think it does. Memoline allocates... The function POSIX allocates size bytes and places the address of the allocated memory in mem pointer. The address of the... Oh, alignment size. Okay. So memoline is going to wrap this. So unfortunately, this doesn't actually do much for us. So how about 20i memoline? Oh, memoline. This is also not getting me what I wanted. I was hoping what we would end up with is there would be a good single place where we can just return from. How about so GDB commands? How do we get rid of that? IB commands to end. So I believe doing that gets rid of all of our commands. Yeah. This too. I disabled it. I want to now enable it. Okay, so we're at malloc here. So if I do print RDI bin print cracks, this looks pretty reasonable. So I should be able to do commands. Actually, yeah, commands to silent. Where were we? Print /x RDI. Continue. Did not want to continue. Try this again. Silent. Print RDI. bin print rex continue. So if this works the way that I'm hoping it works, we should be able to run here. We're at main. I want to enable that breakpoint again. Why are you so unhappy again? It would appear that, again, my computer is being very unhappy. Thought we fixed all this. Come on. Oh, there we go. I do this again, but I'm going to drop off for just a second and see if I can find out what's going on to cause this. But I'll be back. Where are you? I know you're in here. I know you're in here, and I know you're causing problems for me. Why do you not show up? Okay. Okay. So, we have now killed the backups, so they should not be able to run. Yeah, I know the mic was on. I figure just the screen going dead and nothing happening for a few seconds wouldn't be interesting. So, okay. Why does it do that? So, it's what I want, but I also want it to actually continue here. Like, to the Googles. Ah, yeah, here we go. Oh, this looks awful. The claim is that this is a bug in GDB. Oh man, this is kind of gross. Yeah. Okay, I can totally do this one. This one I totally am okay with. So I want to, what is it? Define malloc BP. I want to, what do we want to do? We're going to print /x RDI, bin, print /x racks, continue. But that's good enough. So we now do command 2. I want to silent malloc BP. Do I have to? No, I don't. Continue, end. So we just did here, right, is we define a function in GDB. In this case, it's malloc BP. That function is going to print RDI, which will print out the first argument because we're on x64. We will then fin, which will run until the end of malloc, at which point we'll print RAX. So what we're doing here is we'll print out the argument to malloc, and then we'll print out the return of malloc, and then the breakpoint that we set up is going to, for silent, to not print out anything for us. We're then going to call this function that'll print out the argument and return from malloc. Then we'll continue and we'll end. So we want to disable 2 again, run it again from the start, enable 2, continue. No! You lied to me. You lied to me. Stack Exchange, Stack Overflow. You lied to me. Well, this is unfortunate. Um, hmm. Hmm. Okay, what's this other thing? So this other thing that I can do is I can take this, so I can wrap all of it in a GDB in Python. That to run. Okay, commands to. I want to go away. No, silent. Python GDB dot. So this is gross, and I hate everything about doing it this way. We're going to execute a single command. We're going to execute the print. We're going to execute the fin. We're going to execute the second print. And then we're done. Then we want to continue and end. This supposedly should work. That did in fact work. And I feel very dirty for having used it. No, it did not work. It's probably that silent, isn't it? It's probably killing the output for me. I really hate how difficult this has been. Oh, did we not? Yeah, but it still doesn't work, so it doesn't matter. Well, you know what? We can live with this, right? We can continue. So this is in load state at line. Where are we? So load state, we want to go to line 724. So we just called malloc for file ID, and that returned the stir-duped pointer. Why did that return the stir-duped pointer? Because it's going to be serviced by. No, it should not be serviced that way. Are we just not fitting our sizes properly? I can live with that. In that case, instead of 33, we want 33 plus 16 is 49. And where are we messing with args? So plus 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Dis2, continue, enable to, continue. So we just called malloc for 32 hex bytes in length. That's fine. This time we're doing input sav. We're f opening. Don't care about that one. Why are you still returning that? So these should be getting put into the fast bin. And wow, that is really, really unfortunate. So when it makes that call to malloc of 100 hex bytes, that's going to call the malloc consolidate, which is going to go through. It's going to dump everything out of the fast bins and consolidate it into a single block, which is going to make it so that malloc can return at other places. So because of that, there's not much we can do there, right? So regardless of what we do, when they call malloc consolidate there, it's going to take anything we put into the fast bin, it's going to consolidate it together, and it's going to let it return that to any of the future pointers that are small enough to fit it. Hello, CFI Network. Welcome to the stream. We're currently trying to figure out how to do heap grooming via command line arguments to pdfcrack. And at this point, I figured out why it's not quite working the way that I want it to, which is that when we make this big allocation right here, And actually here, let's print it out so it's a little bit easier to see. Silent x/x, I'm sorry, print RDI, you know what, just continue. Let's disable to, run, enable to, continue. Right. To make this allocation, we then free it. It goes into the fast bins. It's exactly what we want to have happen. The problem is that when it goes and it makes this allocation, it's going to call malloc consolidate, which is going to take all the chunks in the free bin, consolidate them together, which I believe this is probably the only one, but it's going to make those available for this, because now the free bins are empty, so it's going to take whatever the smallest size that's available is. So how can we get around this? What I was really hoping for, because what would work out really well, is if I could take this right here and slide it in up here, basically so that it will overflow this. If we can overflow into this allocation, we are golden. That is exactly what we're going to be able to do, because if we can overflow into that, we'll be able to just smash around inside some, what's the word I'm looking for? Pointers and stuff. Like, we'll be able to crush some pointers. We're going to have just a great day right there. So one thing we can do here is 10, 20, 40, 60 hex. So 60 hex, you know what? At this point, I think we're within the realm of this is going to work, I guess, which is, so we make our malloc. So we make, wait, what? Oh, don't do that to me. So we make a malloc for 94 hex bytes. We then free it. Okay. So what just happened here? What just happened here is when we went to load, we loaded state for input. Then we just trashed those pointers. So if we go back to what we were doing before, so I want to do commands. Oh, no, I don't. It's fine. It's the right one. Silent print RDI in. Might as well just end, right? So disable to, restart, enable to, continue. So this returned 60F010 when we malloc 94 hex bytes. This returned the same thing. Well, that's unfortunate. It also means that it's not quite true what I said before. Right? Because it looks like the... So what I'm seeing here is that the places we're returning from don't really do much useful. But if we keep going, so let's keep going, keep going. Right here. This is at 3.6. So yeah, we're definitely at the top of the heap. Oh, we're hitting, because we renamed the file that it's going to try and open for its word list. Now we're hitting that. Which is unfortunate, because that means we still didn't do exactly what I wanted it to do. Because what I wanted it to do was I wanted it to be able to just grab the... Like, I wanted to slide in someplace nice. But that's not going to work, is it? Let's take a look here. So, 60F00. So this is the heap. So we have 20 bytes allocated for this thing, which this is really where I wanted to end up. Like I wanted to have this free so that when we make our last allocation, we'd be able to slide right in there and make everything work nicely. But it looks like that's not going to quite work out. Although, let me revisit that in a minute. But, so make this, and then this is the file pointer, I believe. It's a handle, it's the file object. We don't care about any of that. This 51, I think, is the one that, like this, if we could bash these pointers, we would be in such good shape right now in terms of doing anything at all, really. There's our file right there. And if we go way past this, so it allocated 1,000 hex bytes for it. Actually, now that I think about it, did we ever take a look at that? So it allocated 1,000 hex bytes. It's got to be doing some sort of internal buffering, right? So that's a stirdoop. It's the stirdoop. This is where we're doing fopen. Where is this? So, oh, that's inside a file. Okay, so that's buffering. I guess that's used for buffering inside of. Huh. I did not know that it worked that way. Or in fscanf, it would do that. Okay, I will buy that that's a thing. Did not know that. That makes it a little bit unfortunate for other reasons too, right? That we've got all that stuff right there like that. So I mentioned that there were some other tricks that we might be able to get away with. One of which, so commands 2. What do I want to do? I want to do silent print /x RDI. Continue. You're not going to let me get away with using Unity. I think it's what, 1704 is supposed to get rid of it for good. Enable to continue. Right. So we're going to allocate 10 bytes for this. We're going to allocate 10 bytes for this and 10 bytes for this. So the problem here, at least what I think the problem here is this is going to be big enough that it won't go into the fast bins. So I think if we do 10, 20, so 10 bytes for this, 20 hex bytes for this, 20 hex bytes for this, that's 20, 40, 50, plus 20 for another allocation. That's 70 hex bytes. Okay. Where are we? Wait, what? No, what are you doing? This very much is not happy right now. I'm not sure why. The problem is that it's not actually the VM that's causing problems. It's that I've got something periodically starting up. There we go. Periodically starting up and causing problems on the host. 1, 2, 3, 4. That got us down to 90 hex bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now 80 hex bytes for that allocation. Drop it one more. And I think when we do this, so we have 7F that we allocated. So 10 of that's going to go, or 10 hex is going to go here. 20, so 30, 50. Then there shouldn't be enough room to, let's drop more off that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, silent, I want to do print RDI, fin end. So we went back to what we were doing. We're going to restart it. Enable 2, continue. So we got 10. It got freed. We allocated the new thing. It's going after it. We allocate for file name. We allocate for whatever that big buffer is. Then this is going to return 10. The next thing is going to return 30. The next thing is going to return 50. The next thing has to go after it. So when we get up here, what we want is we want to make this allocation small enough that it gets serviced by that. So if we do this one, so 10, that goes to 90, that goes to BO. 10, 30, 50. Why did that get surfaced at 370? So we have the 20, we have the 20, we have a 40. Why is there a 40 there? That wasn't supposed to be a 40. That's out of order, isn't it? How did that 40 get in there? So oh, the alignment isn't... Oh, no, I just gave it way more space than I needed to, didn't I? If I shrink that quite a bit more, how much do I need to shrink it? I need to shrink it, because that lines up perfectly, right? So where did 90 get returned? One, two, three, 4. 90 got returned by something. Oh, 90 was the allocation. Oh, right. Let's try this again. No. Is 2, restart, yes. Into, continue. So that's 10, 90. So we need to cut some more bytes off here. So where are we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is 2, continue, run, table 2, continue. That's trying to allocate 5A bytes. That's at 80 now. So AO, 10, 30, 50 can't get returned there anymore because there's not space for it. No, there wasn't supposed to be space there for it. Oh, do I need to take another 10 bytes off? 2. So we called for 5A. So 2, 3, 4, 5, 6, 7, 8, 9, 10. This should be allocating continue, enable 2, 50 hex bytes. 70 what I wanted there? I think 70 was what I wanted there. 10, 30. Yeah, you couldn't get space for it there. So this did return what I wanted. What on earth happened? It's trying to read. So it's crashing in fscanf now. So we got what we wanted here, right? That, oh. Did we, yeah, we messed up one of the pointers in the file. The file object that got allocated. Why did the file object get allocated there? The file object got allocated there. Can we make that happen earlier? So we have 50 here, the 228. So the 228 is from... I don't think I care about that too much, do I? This is a little bit unfortunate, right? So we are completely smashing this file object. The reason why we're getting a seg fault is because we actually messed up the pointers in it. So if we disable 2, restart it, enable 2, continue, continue, continue. So this is the, we're in fopen internal. This is returning that file handle. So if we look at our trace here, this is in the middle of the fopen of input.save. So this is actually going to return the file object, and we'd be able to do something with it. The problem is later on, we're going to overwrite that file object. So what exactly is in that file object? So what does it actually look like? Well, it looks fine to me, right? Got a few options here of things that we could try and fix. I guess one of the options is we just write a whole bunch of null bytes in there. And we write a whole bunch of null bytes in there because that's the problem, right? We're causing a problem when we get to 90. Wait, what? So it would appear that the problem is caused by overwriting the low byte at 60F98. Continue. That's a lot of pointers in there. Unfortunately, as we overwrite them, we're going to do bad things to them. How does this actually work? So if we come back in here, I guess the good news is that we are now actually overwriting something on the heap that's useful. We're getting someplace, finally. When we call this fopen, it's going to allocate a file there. When does it do this? Do I have one up here that's nice and readable? Okay, so we did the 228 for the file. 1,000. What exactly? Oh, we're not going to break on Cialic, are we? Are we? Main.c, line 229. Did that work? That did work. Rerun it, enable 2, continue. Overwrite one of the function pointers. Yeah, the problem is I'm not quite sure what this pointer is, and it's when we're overwriting this pointer we're causing problems. So we've returned from the fopen. The fopen, like the fopen is there, that's fine. I don't understand why What exactly is this first pointer? So what exactly is this thing? Is this a pointer? That's not a pointer. Print star file star. Oh. 60F090. Yeah, look at that. I did not know that was a thing. So is IO read pointer a function pointer? Like, are those, what are those? Let's go find out. To the internet. File. Sure. This is not going to give me what I want at all. This is probably also not going to give us what I want, is it? Seriously? Yeah, this looks good. This is not what I wanted at all. Okay, let's do this the other way. Thanks to the magic that is Google, I think this would give me something decent. Okay. I hate you so much right now, internet. I really do. So those eventually get set, I assume, when we access it, right? So if we continue it, okay. So IO read pointer is going to be a pointer to something. It looks like those are inside, like those are used in that, not in, but they're pointers into that 1,000 hex bytes that we allocated. I guess as long as we make those valid pointers, we should be fine. That's a little odd. I thought Ryan was right, that there should be some function pointers in there, but I don't see function pointers in there. Like, there should be a pointer that I can mess with, but I don't see any in there. Unless is this this is probably pointing at another file object. Yeah, that's pointing at standard error. There's vtable offset, whatever that does. So what I'm kind of thinking here is if we overwrite this with a whole bunch of null bytes, it would work. Well, it won't work. It would reinitialize them, I think. Is that how that works? What is lock? So lock is this thing. No, I want, not gonna work, how are you? I have no idea what that is. So lock is just out here. Okay. So one thing we can do, although I'm not sure how well this is going to work, is we could repoint. We're never going to write into this file. Never mind. So say we could point the right pointer into like our dot or BSS or something. Just blow that away when we wrote to it. It doesn't look like that's going to work. If we none of those are file point, like none of those are function pointers. We do have a bunch of pointers that we can read and write from though. So we could do something like point the read pointer at, actually, now that I think about it, I'm not sure we can do that. because as soon as we do that, like if we mess with the read pointer, we're actually going to end up pointing like into the middle of nowhere, right? Because we're going to, if we mess with that pointer, we're going to read another byte from someplace else. And that's just not going to work at all. Like we might be able to like construct this such that it might work. Let me think about this. So if we can get that read pointer to work okay, if we can get the read pointer successfully read out, and that's going to be gross because we're going to like jump around inside as we do that. Because so the first byte that we overwrite, when we overwrite this byte here, it's going to jump to someplace else to read in the next byte in the file. I guess we could just what's what I'm looking for here. We could just I'm completely blanking right now. This is awful. I'm sorry. We could just line it up to what it should be so that it would work properly. And I guess that would work okay. The problem is it doesn't matter. Because that's a heap pointer, which means that it will only ever work. Like, the only reason this is staying the same is because I'm in GDB and it's just working. So if we ever tried to run this outside of GDB, it's going to fail. Well, that's unfortunate. Seemed so promising. Hmm. Is there any way to skip over that? Does not look like there is. Is there any way to get us something different? If I is greater than 0, we can make input file be stir duped again. I don't know how much that matters. We can make wordless file get stir duped. None of those things seem particularly useful. Because we're still going to call fopen there. The problem we're running into here is that we are bashing this file object. Unfortunately, the stuff that's in the file object is, at least the first several things, are off of, like, they're pointers into the heap to read stuff out of. It looks like in fact, it looks like almost all of them are. Why is there not a function pointer? I was not expecting this fopen to be such a blocker. I kind of expected that this would kind of just work. At least once we got all the heap grooming out of the way. So we're a little stumped on where to go from here. So there's whatever that is. What is this? File jumps? Is that gonna... Even if we... Yeah, I guess that would work. So How does that work? File flags. This is... Oh, I'm actually reasonably surprised that this did not take me to something completely wrong. Yes, kitty? Hmm. No. So I want fopen. Not the PHP version of it, of course. So fopen is going to return a file pointer. What is a file pointer? Hmm. I know that we talked about this a few weeks ago, that standard in at least has some function pointers in it. Why doesn't this have function pointers in it? There's something I can do to kind of trick it not to do that. It's really unfortunate this is blocking this much. Like, being able to clobber the file object seems like we're not in too bad of a position. Problem is like it's not anything useful. Are there anything else on arguments here that might be useful? So I don't care about the word list file, at least not much. Don't care about you stir duping any of this stuff. IO unbuffered. So if you're watching this, Ryan is talking in the YouTube chat and telling me what I should be doing here and am not. Fopen IO unbuffered. Sure. Cool, tell me how to spell things properly. I mean, I guess one of the options here is, so what are we doing? Continue, let's just keep going. Okay. So no, there's not necessarily another chat. I have this open, I have Slack open. I don't have IRC open right now, although I usually do. I was saying it because, for one, a number of people end up watching the streams after the fact. Based on the numbers that I've seen, it's actually the majority of people watch after the videos. And oh, Slack has told me I have a notification. Slack has told me I have many notifications. Look at that. Okay, so he sent me this. So IO unbuffered is the 2-bit. So if I set that, supposedly we might skip over this stuff. Okay, that's easy enough to do. So instead of A's, so A is for 1, we want C's. So if all of these are C's, then we smash the... I don't actually sit in most of the IRC channels. I usually, I'm on Freenode all the time anyway. So like if you message me on... that's not what I wanted at all. If you message me on there or something like that, I would get the message at least. Although today I don't have my IRC open because I started so late. continue, enable to, continue. This is the CALIC. We have this. We still segfaulted. Now I want to do x/20gx. We'll totally change the flags, but we're still, we bash this pointer. So one thing that I was thinking is we could cheat a little bit here. The problem is that by cheating on it, we're not actually going to get anywhere useful. Because if the heap is randomized, like it should be, if we weren't in GDB, we don't know what this pointer is, so we can't do anything useful with it. If we did cheat that way, we could do something like we could change this pointer. So what's actually happening here, right, is 4.5. We're going to write 4.3 into this. And then basically, if we do x/b ox 60f343, that is a 36. Did I do my math wrong? I should have done a 30 there. Anyway, depending on how exactly this is ending up working. So the problem and what's happening here is we're reading a byte at a time as we clobber this data, which is kind of causing problems for us. Is this supposed to be? No, it's not supposed to be. It's supposed to be, this is a real piece of software. As far as an exploit for it goes, it's never going to be useful. Like, the constraints we have to get to the constraints we have in order to even get to anything remotely useful with this mean we control not only the save state for this PDF cracking utility, but we also control the command line arguments to it. And at most we get control like we will get execution as the person who executed the stuff we told them to execute. So in terms of it being like a real world useful exploit, it isn't even remotely. But what it is doing is it's putting us up against some of the kind of real world problems you run into when doing real exploits, where I don't have a ton of options to do heap grooming. I only have a handful of functions I can crawl that will do things. So if I'm looking at a potentially more real kind of exploit, I might not have many primitives that are going to let me do heap grooming. So I'm going to have to work with whatever objects are already on the heap, or that I can somehow induce to be on the heap. So in terms of this being used in any sort of real situation or having any security risk at all, I think at this point we're well past the point of it being a non-existent risk. So yeah, at this point it's basically just trying to get this finished so that we know we're done, we have everything done here. One thing that's interesting and that I'm not quite sure about is where that 30 is coming from. Because it should be, oh, is it F? Oh, I'm sorry, that's why it wasn't making sense. Well, no, those are all still F3s, or 4.3s. Kind of what I would expect them to be. I'm not sure how we're ending up with a 30 there. I don't think it matters too much. Like, we can... Is my math wrong here? So a C is 43 hex, which is definitely setting the 2-bit. It's only setting the 2-bit on one of them. So, you know what we can do? So 4 does not set the 2-bit. 6 does set this 2-bit. So, what are you doing? Oh, because I'm only pressing one lowercase r. Well, so what I'm thinking here is maybe I have the like endiness wrong or something. Okay, let's see here. And that's different, at least. We're still reading from it. Like, we're still ending up the same basic spot. The difference is that we read both 6465. Not sure I follow how we got here. What am I doing? OX60F090. And of course, we are choking again for a second here. I think what I may be doing is tomorrow blowing all of this away and getting it set up so that I don't have problems for the weekend. Getting rid of this would be very good. Come on. Okay, there we go. So yeah, we blew away. How is that happening? Like, I don't understand where that 6.5 is coming from. So I understand the first 6.5. So we set 60F663. We write 1 byte into it. I don't know if there's a goal for it. It's just that's the only thing we can get to overwrite. At least the situation we're in right now, there's nothing there to overwrite that's useful, because when we... I'm not going to be streaming over the weekend. I'm going to be playing, but I want my... This is the same machine I use to play CTF as well as stream from, so I want it not causing me problems over the weekend, if I can avoid it. But so basically, we tried to do a heap metadata attack last week, and the problem is because of the allocations that are made, if we don't do any of this grooming first, we are the absolute last allocation on... Okay, you're right. Now that we can manipulate where we are, so previously, what I was hoping for was that if we did a little bit of kind of fake/real heap grooming. So we use this argument to be able to... So we use the -l argument to cause an allocation, let it get freed, and have stuff slot in kind of where we wanted to be able to overwrite other things. Because if we don't do that, we end up at the very top of the heap, because nothing else is freed up until this point. And the problem is that if we're at the top of the heap, we can't do much with the metadata there. The only thing we can do is we can bash... Well, so the only metadata after us is whether or not our block is in use for consolidation and the amount of unallocated space left in the heap. And if we can't control the sizes of future allocations, which it doesn't look like we can't really do anything with that. Like, we can definitely cause some problems, we can cause some crashes, but the crashes are going to be when basically during cleanup, and it doesn't matter much. We can't get anything useful out of it. If we could control the sizes, we can do the... I looked it up last week. One of the house of whatever attacks that basically you overwrite that available space, and then you make a large allocation of a size you control that will let you overwrite an arbitrary pointer. The other problem with that is that it's at least somewhat reliant on you knowing where the heap is. But one thing we can do here, and that I hadn't thought about that much, is what if we don't overwrite all of this? So what if instead of overriding all of this, we just mess with the metadata on the file object? I'm not sure what that does. So the file object, so we fopened it here, and I assume when we close it is when they free it. So what happens? What we might be able to do here, where is it? So we have file is this. We close it after, so we will load our state and then we'll close it and free this object. What can we do with that? So if we change the size of the file object, we can definitely cause some problems. The question is, what problems can we cause? To start with, I think the only heap metadata attack that's going to be useful here is we're going to be able to resize the file object. So when we go to free it, it's going to free a block of memory on the heap that is not just the file object. So we could, even then, what does that get us? So let's say we somehow get some overlap. What if we do the most basic thing, right? We just say that we're free still. If we overwrite our pointer, our bit, our free bit, what does that do for us? It means that when we free file, we're going to, no, that doesn't do anything useful for us either, because we're still, like, we can't write into this thing again. It's a really unfortunate blocker. Okay, let's go check this again. So we have this bug in the what if we take advantage of this instead? I did not think about this. So wordlist file, we will also free wordlist file if wordlist file is set. The wordlist file is something we can set. So the -w argument will set wordlist file. And we'll free it here as part of this. What does that do for us? So we can make a hole for ourselves just before all of this code. What I'd really like to be able to overwrite, like if I could get it lined up just right, I'd love to bash this E. So E is this enc data object here, and it's just got tons of pointers in it. But unfortunately, it's ordered just wrong for us to be able to do that. We can't get in between those two. Or can we? Interesting. So if we line it up so that wordlist file, so it goes wordlist file, the buffer that we're going to have free, so to the paints. Okay, so if we have word list, and then we have, what is this thing called? Input file. Input. And we free this thing, and then we call we get our f open, and f open is going to be up here then. Really do kind of wish I had a tablet to do that with. That goes up here. Then we free this. We might be in good shape if we did that. If we did it that way, so we need to make sure that the word list argument gets read first. That it comes in first. Basically set it up so that the word list file is the thing of the size we want. And that I want to be in here, and I want this. So I want that calloc able to run, yes. Enable 4, continue, enable 4, continue. So calloc is called with whoa. What? That does what? I'm so confused. Okay. RSI should be the second argument. I guess maybe that takes different arguments or something. Not different arguments, takes different calling convention, but so where were we? So if we set it up so that instead of being the big size that we want there, that the -L that gets freed is 40 hex bytes, and the -W for the word list file is this big thing that we actually wanted, I think we'll end up back where we want it to be. Source line maps to several instructions. So I broke. Oh, I'm on main, aren't I? What is breakpoint 3 on main? Oh, it's because I'm actually not where I thought I should be at all. I have 2 breakpoints there. This is the one that I wanted. That is what I wanted. I had an additional breakpoint and I was not where I thought I was at all. So the -W argument, if we make that the -L argument we have, where did we put this? So this is going to be a -W argument. And we want our -L argument to be, okay, so we want this to be 40 hex bytes. So that's 4, 8. That is not 8. That is 6. That is 8. That is 16. I want it to be 64. So yank 16. That should be 32. That should be 64. So if we do this, wait, what was the ordering for this again? So we want -L to be second. So we want the -W and the -L. Right? We want the 40 to end up immediately after the -W. I think this is what we want. Oh no, I deleted it. Silent print RDI fin continue. Well, I guess it doesn't matter too much. Continue. Okay, so we got our 50. Got our 50. No, that's right. we got a 40 hex. We got our 10 hex. So if all this works the way that I think it should, then we go OX60F000. We should see that that's still in use. Both of those are still in use. No, this is now, so this is the first dash L argument is now not in use. It's in a fast bin, so it's not marked. Let's continue. We're now doing fopen. Fopen is well past us. Good. We're allocating other stuff. Okay. So if we do this, 60F010, what I'd like to see here, but that I don't see here, maybe that's what I wanted to see. This is what I wanted to see there. What did we bash? How did this happen? So come on. Oh, did we just smash all the way into it? Yeah, we just smashed all the way into it. We just have way too many bytes here. How many bytes do I want to smash? I want to smash 1, 2, 3, 4, 5, 6, 7, 8, 80 hex bytes, which is 128. I want to do this. Dis 5 in 5. Of course you're choking. Oh, there we go. Aha! We have smashed something there. That is what I wanted to see. We have successfully smashed the pointer, a pointer that they're trying to free now, which isn't exactly what I wanted to see, but I can live with that. Oh, if we go do this instead. So at this point, we now require we're apparently, we've overwritten the security handler pointer, what this looks like, which is just breaking everything. Which is good. At this point, we've smashed several of the pointers in the E structure, which is what I was hoping we would get out of it. So, what's the next thing we want to do? So again, what we did here, let's pull this up so that it's a little bit clearer, is we set it up so that it would allocate a word list, it would allocate an input, we would then make it allocate another input, which would cause it to free this one and allocate some space for another one. Then it would eventually free the word list because it knew we were recovering and didn't need it. We then made this fopen object, the file object for that, and we don't actually care about the stuff after that. What is important is that after the fopen, we're going to put the e struct in here, which falls into this bucket, so that when we have the word list, we'll eventually get in here and we'll overflow all of this. And all of this stuff here got smashed, including several pointers in the E structure. So what we need to do now is we need to go through the code and find out a way to use that. Ideally, there's going to be some place where we're just going to write to one of these things. So here we have that the security handler is getting printed from. So if we go to 290, we called print. So if not quiet, we will print enc data. Print enc data will do a, yeah, we printed, I suspect that if we converted these are CC in decimal. So print OX 61616161. What are these? 6 3s. Oh, right, because it's C, lowercase c's, not lowercase a's. But yeah, so when we try and print out the S handler, this fails because if it's set, we try and print it. So we can set this to be a real pointer if we want to, but I don't know what that's going to do for us yet. We then print out all this other stuff. I don't know how much this matters. Eventually this is going to like print off a whole bunch of junk. Oh, that's not what I wanted. How do we set it to be quiet? Skipping over this would be kind of nice. But we init pdfcrack. We took in E. We will init workspace. Actually, let's do that real quick. So how do we become quiet? We give it a -q argument. -q. Run. Continue. Okay, where do we end up here? So this time, we are in the init key workspace where we crashed. So I want to be in 299. We got in here. We then got to 614, which is init key workspace. And this is at 121. So at this point, we tried to memcopy from owner key into enc key workspace, which is not going to work because owner key is a pointer that we controlled, which is complete junk right now. That's a, what's a right 8? No, we don't control the enc key workspace. That's being mallocked up here. I'm looking for one, but we need to fix all this other stuff first so that we can actually successfully work. Yeah, we do get several arbitrary reads. I'm not sure what the arbitrary reads are going to do for us though, because again, this is just a file parser. Like it's parsing a save state, which you can't modify after the fact. Although it is a good habit to be in to notice that kind of stuff for people who haven't done any sort of real-world exploitation. Keeping a lookout for information leaks and memory disclosures and things like that, being able to read bytes out of arbitrary addresses is usually incredibly useful. When you're attacking most modern systems, it is completely insufficient to have one bug. You need some sort of memory corruption to do something, but you'll also need some way to leak out pointers because of ASLR. And if you don't have both of those, you can't do anything at all. Sometimes you can turn memory corruption into a leak, but not always. So having an eye out for them when you're looking at code is very useful to have. And what Ryan is pointing out is that this memory corruption we have, we could turn into the ability to read 8 arbitrary bytes out. It's just in this case, because of the setup we have, I'm not sure it's going to be completely useful. But so we need to make, what is it, EO string be a valid pointer because it's going to try and read it from here. Permissions we don't care about, so none of those we care about, but we need file ID to be a valid pointer. Although we can get more heap corruption here because we're going to control this value too. It's just not going to matter that much. This is a little interesting, but no, it's not. Never mind. So basically, we need to make sure that file ID len is something sane, that file ID is a valid pointer, and that owner key is a valid pointer. So that is the last three arguments here are all valid pointers. But let's keep looking on. I don't want to go to a whole bunch of work to fix all these up to be valid pointers and then not get anywhere useful. So PM, file, WL, CS, min, PW, those are all arguments to this function, none of which are currently being manipulated, I think. We don't care about those. Don't care about that. E length needs to be valid. Man, I was really hoping we would end up pretty quickly. So O string and what was the other thing? So when we were in here in the load state, we set up a whole bunch of stuff here for us. But what's important, at least what I think is important here, is we're going to have this S handler that we'll write into. We have the O string and the U string. Are these the only place they're going to get read from? O string. So they will potentially get used there. The memcopy is reading from it. The memcopy is reading from it, reading from it, reading from it, reading from it, reading from it. I don't know what this one is. This is where we're setting it up. This is writing to it, but it's during this initial setup before we've overwritten anything. Nothing, 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 nothing. If it's set, we free it. If it's set, we'll read from it. And here we set it. So none of these are using it for a write anywhere, except for maybe the RC4 stuff, but I don't think so. I suspect what's happening there is we're using the, like we're checking RC4 password, and there's a comparison there. What's unfortunate is I suspect that we're actually in the same spot with the other ones too. One way to test this is we know that print x/x main. So this is a valid pointer that we can read from, but we cannot write to. So if I go in here, FOOO. So this is where we were. I don't remember. You know what? No, let's do this the easy way. Where were we? This thing. So we have 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. we're going to do f1 is equal to, or we're going to read it in. We're going to open it, to write base, and we're going to write import star pack 64 OX 401080 times, so we have this right here, that 1, 2, 3, 4, so 1, 2, 3, 4, 5, 6, 7, 14, 15 times. So I want to cp input.sev base.sev Python. Yeah. Okay. Huh. That did not work. Why is that a new line? I mean, that's the problem there. There's a new line there for some reason. Why is there a new line there? Why would there be a new line there? DCC, CCC, 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 new line. I feel like I'm crazy here. Okay. Not quite sure why I had to do that, but interesting. So I think we might be triggering the uninitialized function pointer thing that we had previously. So for people who were not watching the past couple weeks, one of the bugs that we kept running into, one of the crashes we had a ton of times, was that there is a function pointer which under certain situations is uninitialized, and they call it anyway. So the end result is if we are hitting that code path, we're going to have to figure out what exactly is causing that to be uninitialized and initialize it so that we can actually get a, yep, that is exactly what's happening there. So there's that uninitialized function pointer. So when they're initializing, so if we come in here, we want pdfcrack. So I want yes. So Ryan was asking if we fuzz this. So we ran AFL on it. So the first week we ran AFL on it. We fuzzed the, well, so actually, let me start from the beginning here. So to start with, I cheated. I started running AFL on it, and then to verify that I could find what looked like an exploitable bug, I did some source diving and found the bug we're looking at right now. That was very clearly, as soon as I saw it, there was a heap corruption there. So after that, we fuzzed it some more. We fuzzed first the basic input. That turned up nothing useful. Then we switched over and fuzzed the save state files, which is where this bug actually is. So we spent about a week running AFL on it. I think it was close to 500 million test cases we got through it in that time, just running it on EC2. And I believe there were two different pathways to the to this uninitialized function pointer, because there's two different ways to initialize it. Then several ways to get null derefs for various reasons, and then several ways to get asserts. But this is the only one that we found which was heap corruption. Even when we turned on ASAN. One thing that might be useful, and I'd probably put a lot more effort into looking into if it was a real target, was there was one condition that ASAN turned up towards the end of the week of fuzzing, which was slightly different, but running it outside of ASAN looked completely valid. Oh, no, I don't want to do that. So anyway, where were we? We were taking a look at this. We were at line 418. So we call MD50. The problem here is that in order to call MD50, we need to have initialized it first. And apparently we never called MD50 init so that we could initialize it. How do we initialize it? Does this initialize it? Run crack does not initialize it. Right? This is just a awful if else if else if else if. And this looks like the kind of code that I might write. Anyway, oh, what's going on here? Come on. I've apparently broken something. One of the many things that can... Oh! Wow, what just happened there? Okay. Where were we? Actually, it's about 9 o'clock. Might be about time to wrap it up for the night. Looks like we may be doing one more week of this, since we finally have progress. I think what I'm going to end up doing is I'm going to basically start this up again, trying to explore what we can do with this. Actually, now that I say that, I had wanted to play a little bit with Manticore. And one thing that I think it probably should handle reasonably well is I can control this set of bytes on the heap. What can I do with them? Just let me explore that a little bit. So I think what I might do is try and get that set up a little bit and try and do the magic of constraint solving and symbolic execution, all those magic terms, and see if I can figure out what exactly I can do with this structure that I'm able to overwrite. So just to recap for people who have missed previous weeks, in week 1 we did pure fuzzing. We basically set up AFL, we talked a little bit about how you do fuzzing, we did a basic look through the file. Then the second week we took a look at The second week, we took a look at the output. So we triaged a whole bunch of these crashes. We dug through them. We talked about using ASAN and things like that, using it to get better results. And then this week, we've gone back and we've tried to actually land it. Last week, or 2 weeks ago, we tried to land it and failed because I couldn't get the heap grooming exactly right. We spent about half the time doing triaging and then another half hour or so trying to do it without the heap grooming and digging through and seeing if we could find anything. Eventually giving up, deciding to do the heap grooming, failing at the heap grooming, and basically putting it off to this week. So this week, we finally got the heap grooming correctly. We can now overwrite the object that I've been trying to overwrite. And at this point, we now need to decide what to do. So with this object, it's a complex object with a ton of different pointers in it. Hopefully, at least one of them is going to let us do something useful after we can overwrite it. But at this point, not quite sure. We'll have to take a look. So I guess we're going to do one more week of it, and hopefully next week we'll get a chance to really poke it pretty hard and get something useful out of it. So that's about all that I have for this week. Like always, if you have any questions or comments, feel free to message me. Twitter or Slack is probably the easiest way to do that. I'm on the Buyer Ninja Slack, the Empire Hacking Slack, several other Slacks as Murmis. Feel free to message me there. I'm also on Twitter at MurmisCTF. I'm on Freenode and several other IRC channels as Murmis. Feel free to message me or if you have questions or comments on any of those platforms, or leave a comment on the video. And also, you should totally play in DEF CON Quals this weekend. It's probably going to be a good, hard CTF. It should be a lot of fun to play in. I plan on spending all weekend staring at my computer and hopefully not literally smashing my head into it. Hopefully it will be more of figuratively smashing my head into it and literally solving challenges. But we'll have to see how that works out. The literally solving challenges is not as much up to me as it is to the challenge designers. So other than that, thanks everybody for checking in. And I guess I will see you all on Monday. Bye.